So we were talking about Dalton's law of partial pressures, collecting gas over water. When we collect a gas over water, we get a mixture of the gas we're collecting and the water vapor because water evaporates. And the pressure exerted by the gas of water vapor, is called the vapor pressure of water. It's very cryptic. The vapor pressure of water depends on the temperature. And so here's an example of a table. You can look up much more detailed tables. But at 0 degrees Celsius, the partial pressure of water is very low. Up at 90 degrees Celsius, which is getting close to the boiling point, the pressure is much higher. At 100 degrees Celsius, at the boiling point, the partial pressure, the vapor pressure of the water equals the atmospheric pressure. So to find the pressure of the gas that we were interested in, we have to look up the vapor pressure of the water at whatever temperature it is, and we subtract that from the total pressure. Because the total pressure is the pressure of the gas we're interested in, plus the pressure of the water that just is there because it is. We didn't put it there, but we can't get away from it. So let's do an example. An unknown gas is collected over water at 60 degrees. If the total pressure is 763 torr, what is the partial pressure of the unknown gas? Anytime you see collected over water, you're going to need vapor pressure of water. So let's go back to this table. There it is. And it was 60 degrees. So at 60 degrees, well, that's not a good color. 60 degrees, we have 149.4 torr. So short-term memory, 149.4. So the vapor pressure of water, partial pressure, pH2O, 149.4. Did I get that right? Torr. So that number is not given to us in the problem, but they give us the temperature, and then we have to go look it up. On an exam, I would either tell you what the vapor pressure of the water is, or I would give you the table so that you could look it up. The total pressure is 763, so that's the total pressure, 763 torr. Oh, I left off the 0. 0.0 torr. So we need to remember Dalton's law of partial pressures. The partial pressure of the water and the partial pressure of our unknown gas add up to give us the total pressure. And so we're going to solve for punk. P unknown. It looks like punk. So punk equals P total minus pH2O, which is that fan bothering anybody else?
Yes.
Good grief. 763 torr minus 149.4. Anybody have a gun? We could just shoot it. No, you shouldn't have a gun because it's not a good idea to bring guns on campus. That's really a bad idea. Maybe we could find a hammer. 613.6 torr.
Melt it with the Bunsen burner.
Yeah, maybe we could melt it.
With our minds.
Yes, because our minds are so brilliant and hot. We could just, let's all focus our mental energy on that fan.
It's horrible. I hear it all the time.
I know. You don't have to sit under it. You could sit over somewhere else.
You're still going to hear it.
Well, you're still going to hear it, yes.
It's not going to be as bad.
So we apologize to the YouTube community for the squeaking in the background. It's a fan and we can't do anything about it. Okay, 613.6 torr. Any questions?
Can you go back to
The table? Mm-hmm. I think I can.
So just go to 60 degrees.
Yeah, you just go to 60 degrees. You look up the temperature, and you see what the pressure is at that temperature. This table doesn't give you a lot of detail. You know, it gives you basically every 10 degrees, and they throw in 25 because that's a typical room temperature. There are other tables, like I found one on the internet yesterday for my other lab, that does it in half degree increments. So 21.0, 21.5, 22.0. Any other questions?